Hi, in this video I'll talk at high level about how you architect solutions on AWS. AWS has created the well-architected framework, and this framework helps individuals create solutions that best leverage AWS by following a set of best practices. Now, the well-architected framework has 5 pillars that they recommend for these applications. First, operation excellence. So, they go through best practices about how you run and monitor systems that deliver business value. Then, security. Because we want to be protecting the information and business assets that we place in the cloud. Then, reliability. And this is talking about enabling infrastructure to recover from disruptions. Performance efficiency. We want to be sure here that we are leveraging what we need to achieve the business value that we want to achieve. And then cost optimization. We want to be sure that our costs are no more than they need to be. So let's talk a little bit about reliability on AWS. First, we have fault tolerance. And this just means that you are able to support the failure of a component within your architecture. But in addition to fault tolerance, we have another topic, which is high availability. Now, this is similar to fault tolerance, but it has to do at a higher level with your entire solution running in an expected manner despite any issues that you may occur. And this is where you are able to take advantage of another set of AWS services to make sure that your application stays up and running no matter what may happen. Now, one of the aspects that we deal with on AWS is disaster recovery. So even organizations that leverage their own data center can take advantage of building and architecting solutions that enable them to be spun up in AWS if something happens. Let's say a natural disaster at the organization's main data center. AWS lays out 4 architectures that should be considered for disaster recovery. First, we are going to look at backup and restore. With the backup and restore method, organizations simply back up their key systems and they are stored in such a way that when a disaster recovery event occurs, they are able to restore those onto the AWS to restore service. Next is Pilot Light. This is a step beyond backup and restore. In this case, minimal resources are set up in AWS to support. Now, this could be something like you keep a version of your database server that's actually being replicated from your master server into the data server, so that if this event occurs, you could shift over the traffic, scale up and be able to support the needs within AWS. Then we have warm standby. Now in this case, you are going to have most of the infrastructure needed for running in AWS. However, it's probably not scaled yet to actually meet the load of your users. But in this case, it's ready to go at a moment's notice. And the fourth approach is what we would call multi-site. And through this disaster recovery approach, you are continually leverage both your data center and AWS, and you are actively sending users to both. And this is what we would refer to as an active architecture. As we transition from traditional environment where we own and control all of our data centers into a cloud platform, it can be difficult for us to know what is the responsibility of the cloud provider and what is our responsibility. AWS provides a shared responsibility model, and the core tenet of this is that the security and compliance is a shared responsibility between AWS and the customer. So AWS is responsible for the security of the cloud. So if you think of all the data centers, everything that supports those data centers, all of the individual pieces of equipment that are there in the data centers, that's the responsibility of AWS. But as a customer, you are responsible for the security in the cloud. How you choose to leverage those services and how you choose to leverage the virtual servers that you spin up, those things are your responsibility. AWS is responsible for access and training for Amazon employees. So who has access to data center? Who can access a specific service to administer it within AWS? Those are the examples that AWS owns. They also own all their global data centers and the underlying network that connects those data centers. Those are the things that they will own and maintain and keep up to date for the platform. They also own the hardware for the global infrastructure. So if you think of all the network switches, if you think of all the cables that are going to connect, or if you think of all the physical servers, these are the things that they're going to own and control and keep up to date. In addition, they are responsible for configuration management for that infrastructure. So this includes things like identifying changes, deploying those changes, monitoring the health and state of a particular service. They're also responsible for patching and the cloud infrastructure and services. But on your side, as a customer, you are going to own the access to the cloud resources and to training. So you need to be sure within your organization, if you give someone access to AWS, that you are giving them a permission level that is appropriate for what they need to do. Also, data security and encryption is your responsibility. Many people falsely assume by simply putting data into the cloud that it is automatically protected. But you choose on AWS on how to store the data, both in transit and at rest. And so if you choose to actually store the data on a service like Amazon S3 or a database like RDS, you can identify whether to encrypt or not. And then when we are looking at data in transit, that means we are passing data from one service to other service or from one server to another server. You can choose to leverage encryption or not leverage encryption for the transfer. In addition, it is your responsibility for the operating system, network and firewall configuration. So if you get a virtual server that's been launched, you are responsible for administering the operating system of the virtual server. And also, when you create a VPC and you actually have your network, you are going to have the ability to control what traffic can go into and out of that network. You are also responsible for all code that is deployed onto the cloud infrastructure. So AWS can't control every bit of the code that you write. So it is your responsibility to make sure that you are using the service responsibly and in a way that protects your information. But you are also responsible here for patching the guest operating system and custom applications. So while AWS owns all the base level operating system, actually on the physical servers themselves, you are going to be responsible for patching your level of operating system. AWS shared responsibility models helps us understand as a customers of AWS what ultimately they are responsible for and what we are responsible for.